Hey guys, so in this video, we're going to discuss Leetcode 2402, and this is a coding question asked in Google interviews. So for this problem, we're going to be given an integer n, means we're going to have n rooms numbered from 0 to n minus 1, and we're going to have a 2D array of meetings, and every meeting will have a starting time and ending time, and it's half closed, which means the start time is inclusive and end time is exclusive. And the meetings are allocated to the rooms with the following rules. So every meeting will take place in the unused room with the lowest number. So this means like if we have three rooms available, like room like 2, 3, 4, then we're gonna use a room 2 because room 2 has the lowest room number. And if there are no available rooms, the meetings will be delayed until a room become free. And the delayed meeting should have the same duration as the original meeting. So let's say if a meeting from 10 to 20 is delayed to starting from time 15, so then the meeting will have a duration of the same time unit of 10, and it will last from time 15 to 25. And also, when the room becomes unused, the meetings has the earliest original start time should be assigned with the room. So this means like all the meetings should be held in order, no matter like if they are delayed or not. They are always held in order. And then we need to return the number of rooms that hold the most meetings. And if there are multiple rooms meet the condition, like have the same number of meetings they have, then we return the room with the lowest number. All right, so for this question, so since like we need to hold all the meetings in order, so of course we need to sort the meetings so that we can like process every meeting in order, and we need to like take the meetings like available meeting with the lowest number available. So usually we only care about the lowest number, and we don't care about the order of that. Then in this case, we can use a heap queue so that we can have a like time complexity of log n to process on the heap queue. Like we have order of one to pop from the heap queue, and then order of log n to push into the heap queue. So this is usually what we use when we only care about the lowest number case. And also when a room become available, so usually like when the room become available is like when the ending time is the earliest. So we need to use two heap queues in this case. The first heap queue will be used for the available room so that we can pop out the available room with the lowest number. And the second heap queue we're gonna be used for the rooms like are already in use, like the in use rooms, so that we can pop out the the in use room with the earliest ending time, so that we can know when it will be free. So, okay, so now we need to use two heap queues, right? And also we need to sort the meetings, and then we can just like process the meetings in order. So let's sort out the algorithm. So we need a heap queue. Right. And as I mentioned, we need two heap queues. One heap queue is for the available room. And originally, we will have like all the rooms will be available, so we can just like initialize the available room heap queue as this in range n. And then we're gonna have also like in use rooms. This is the heap queue. Like originally there will be no rooms in use, and also we need to return the room with with the most number of meetings. So we can just have a room usage indexed with like initialized with this, so that every room will have a usage of 0. So initially, and we're gonna sort the meetings as well. Then we can process the meetings in order. So for start and end time in meetings, so now we're gonna process every meeting. So first of all, like we need to like when we have a starting time, right, of the meeting, so we need to release the in-use rooms, which the end time is lower than the current start time, so that we can mark the room as available. So let's say the first step is to release, sorry, release in use rooms. Oh, click the wrong button, sorry. Release in use rooms. So while we have in your room and the okay, so for in use room, right? So every item will be the end time plus room number. So and in use we're gonna pick the in use room. So the first item, the end time. So the in use room with the lowest end time is less than or equal to the start time. It's gonna pop it out. So heap queue or heap pop. In use rooms and the values. So it will be the end time and the room number. Oh, pop it. And then this room will become available, right? So we can just heap queue or heap push it into the available room. So this room will become available. All right. So now we release all the in-use rooms which whose time is less than the current starting time, right? And now we're gonna assign the meaning to the rooms. So let's say if there are available rooms, then it will be easy. We can simply so if there are available rooms, then we can simply just get the available room with the lowest value. So room will be heap pop the available rooms. This will be the room to use. Now we can push it. This room will be in use, right? So we need to push it into the in use room. In use room, and then we're gonna every item in the in use room will have an end time and the room number, end time and the room to use. Otherwise, if there's no room available, right, we're gonna find the in use room with the earliest end time. So with the earliest end time, that will be the room we're gonna use. So and this end time will be the new starting time, the new start time for this meeting. So now we're gonna push this to in use with room to use. So since this is a new start time, right? So the new end time would be start time plus, let me just do it here. New end time would be the new start time plus the end time minus start time, which is the duration of the meeting. So this is the duration, right? Plus the new start time. So this will be the new end time. All right, and then we need to update the room usage of the new room. Room to use will be incremented by 1. So now we find all the room usages, and we just need to find the maximum usage of all the rooms, right? So maximum usage will equal to room usage, the max of the room usage, and then the max room just equals to room usage dot index of the max usage. This is the room we need to return. Return the max room. Yep. So this works. So for time and space complexity, so we sort the meetings, right? So it will be n log n, and Also, for every meeting, we're gonna do a heap queue heap push algorithm. So it's still n log n. So total time is n log n, and the space will be order n because we have these like three data structure to store the data. All right, so this is the end of the meeting, and I'll see you guys in the next one.